A very warm welcome everyone. So today in this class we will be continuing the chapter Gases, Unit 16 under Subject Science and Technology, Class 9. So I hope you all are prepared with everything you need, your notebook and pen, because today we will be studying about the nitrogen gas. As you all know, Earth is covered by atmosphere which contains many gases, and among which nitrogen is found in the highest amount, that is about 78% of all the atmospheric gases is nitrogen. And not only in atmosphere, it is also found in organic compounds like proteins, in plants and soil, as well as DNAs and RNAs. One interesting fact about nitrogen is it is an inert gas. It does not react under normal condition. So, why is nitrogen gas an inert gas? Can you guys guess? It is because nitrogen molecule has triple bond. The two atoms of nitrogen combines with three bonds. So, breaking that bond so that the atom from the molecule, it dissociates to form an atom, and for that atom to take part in the chemical reaction, it requires a lot of energy to break that bond of the molecule. So that's why nitrogen does not readily take part in chemical reaction, but it takes part in certain chemical reaction under special condition. So in normal condition, it is inert, hence it does not take part in the chemical reaction under normal condition. So let us study a little more about nitrogen gas. So nitrogen is represented by the symbol N. The atomic number of this element, that is nitrogen, is 7 because it contains 7 number of proton in single atom in the nucleus of the single atom of nitrogen. The atomic weight of nitrogen is 14 because it contains 7 number of protons and 7 number of neutrons in the nucleus of one atom of nitrogen. So 7 plus 7 is 14. That's why its atomic weight is 14. Its molecular weight is 28. So why is the molecular weight of nitrogen 28? I think you can guess that because we have already studied similar thing about hydrogen and oxygen as well. Yes, it's true because two nitrogen atom, it shares 3 electrons in its outermost orbit with each other to reach the stable octet state. So here you can see that nitrogen has 5 electrons in its outermost orbit, among which it shares 3 electrons. Each atom shares 3 electrons to form triple bond. This triple bond, and due to this triple bond, nitrogen is inert in under normal condition because it requires a lot of energy to break this bond. So nitrogen is also a diatomic molecule, and molecular weight is 28 because a molecular weight is the sum of the atomic weight of individual atom present in that molecule. Since the atomic weight of one nitrogen is 14 and the another nitrogen is also 14. So 14 plus 14 is 28. That's why the molecular weight of nitrogen is 28. Now the valency of nitrogen is 3. When nitrogen takes part in the chemical reaction under special condition, it shares 3 electrons present in its outermost orbit normally, and since valency is the combining capacity of an element with another element or radical, so since it shares 3 electrons, that's why its combining capacity is usually 3. That's why its valency is also 3. The density of nitrogen is 1.25 kg per meter cube. Now let us study a brief history about nitrogen. So Daniel Rutherford discovered this inert gas in 1772 AD, and after some time, Jean Anton Chaptal named this gas as nitrogen, that is in about 1790 AD. Now there are various methods in which you can prepare nitrogen gas. So there are 3 points that you must remember, which I've already mentioned in the previous 2 class to select the method for the laboratory preparation. That is these 3 points. It should be inexpensive, rate of reaction should be moderate, and it should be simple to prepare so that you can prepare it by yourself in the laboratory. So taking all these three into consideration, for laboratory preparation of nitrogen gas, what we do is we heat the mixture of sodium nitrite and ammonium chloride. Now I'll show you this reaction. Now let us write this chemical reaction. So sodium nitrite plus ammonium chloride, in the presence of heat, it gives us sodium chloride plus water and nitrogen gas. Now this equation is not balanced. There is one atom of sodium, it is balanced. 2 atom of nitrogen, 2 atoms of nitrogen is balanced. Chlorine 1 atom, it is balanced. Hydrogen, here is 2 atoms of hydrogen, here is 4 atom of hydrogen. So hydrogen is now balanced, and here there is 2 atoms of oxygen and 2 atoms of oxygen. Now this is the balanced chemical equation, and using this chemical equation we will synthesize nitrogen gas in the laboratory. Now let us prepare nitrogen gas in the laboratory. For preparation of nitrogen gas, I have already mentioned earlier, we will be using mixture of sodium nitrite and ammonium chloride. For the chemical synthesis of nitrogen gas, we will take 2 chemicals. The first one is sodium nitrite, which is taken 5 grams, and the second is ammonium chloride, which is taken in 4 grams. Now, a mixture of them is made using 50 ml of distilled water. So let us measure 50 ml of water. Now the apparatus required are round bottom flask, thistle funnel, delivery tube which we have already bended according to our need, spirit lamp for heat source, beehive shelf, gas jar, water trough and clamp stand. Now let us set all of this apparatus up for the laboratory preparation of nitrogen gas. This is how we should set up the apparatus. Now we are using this 2 wooden block because we are not using Bunsen burner and tripod stand. Since the height of the tripod stand is much more than that of the spirit lamp and the heat would not reach the round bottom flask, that's why we are using this wooden block just to maintain the height according to the spirit lamp. Now we will pour these 2 chemicals that we had prepared into the round bottom flask. Now we will pour the water, 50 ml of water that we had measured into the chemicals so that we can make the mixture. Now let us apply heat. We are placing the Bunsen burner because the heat we are going to apply should be very gentle, because the reaction itself that occurs here is exothermic. That's why we are using this wire gauge. We haven't placed the gas jar yet because the air that is contained previously in this round bottom flask and the delivery tube would get mixed up with the nitrogen gas produced, and the first gas that would rise over here in form of bubble would be impure. So we will let that pass for a while, then only we will start collecting the pure nitrogen gas. Now you can see that the reaction has already begun. You can see that the air bubbles have started to rise. Now let us collect the pure nitrogen gas, as we have already allowed some of the impure gas to be released. The gas jar should be completely filled with water. Then it should be entirely dipped into the water. Then only the cover slip should be taken out. You can see that the nitrogen gas has started to get collected by downward displacement of water. You can see that the gas charge is completely filled with nitrogen gas. Now to confirm if the gas is nitrogen or not, we will burn this magnesium ribbon. You can see, since nitrogen gas is not a support of combustion, since the magnesium ribbon still is burning. So this proves that this is the nitrogen gas. And you can see that there is whitish powder. If we add a few drops of water, you can smell the strong smell of ammonium gas. This also proves that it is the nitrogen gas. As you saw that we have already prepared nitrogen gas in the lab. Now let us study about its physical as well as chemical properties. Now we just produced nitrogen gas in the laboratory using this equation, that is by heating the mixture of sodium nitrite and ammonium chloride. Now let us recall all the precaution that we took in the laboratory, so when you guys will try to synthesize this gas in the lab, there won't be any accident. So the first precaution that you must take is all the apparatus should be washed and dried well. The apparatus should be airtight, for which you can use candle wax, which I have already explained to you in the previous classes. The mixture should be heated gently, for which in the laboratory you saw that I used the wire gauge in between the mixture in the apparatus and the spirit lamp below, so that there is a gentle heat reaching to the mixture, since the reaction itself is exothermic reaction, which means the reaction itself releases heat. So that's why we have to only supply gentle heat to the mixture. Another very important precaution you must keep in your mind is the solution of the mixture needs to be prepared before heating, since ammonium chloride undergoes sublimation. So when we are heating the mixture of ammonium chloride and sodium nitrite, what we should do is we should first form the solution by adding water, which I showed you in the lab, and after forming the solution in the water, then only we should heat the solution, because if we heat the solid mixture, what happens is ammonium chloride is a sublimate. What is a sublimate? Any substance that changes from solid state to vapor state is a sublimate. So when we supply heat directly to the solid ammonium chloride, it changes into vapor state. So to prevent that, we make a solution of the mixture first, then only we apply the heat. So you must remember this point. The solution of the mixture needs to be prepared before heating, since ammonium chloride undergoes sublimation. Now the another point is the tip of the thistle funnel should be entirely dipped in the mixture, so that the produced nitrogen gas will not escape from the thistle funnel. But the tip of the delivery tube should not be dipped. Why? So that the produced gas can be delivered from the apparatus to the gas jar and can be collected there. So the tip of the delivery tube should not be dipped. Another point is the gas jar should be completely filled with water, because the incompleteness in the gas jar would be air. So the produced nitrogen gas will get mixed up with the air, and the resultant nitrogen gas that we collected will be impure. So that's why you must remember that the gas jar should be completely filled with water. Now, I have already explained this test while we were performing it in the laboratory, but I'll explain it again so that you guys will remember it for long term. So, how we can test if the produced gas is nitrogen or not? What we do is we take a burning magnesium ribbon, and when we are burning it in the air, it gives us white product because magnesium reacts with oxygen to form magnesium oxide. And that same burning magnesium ribbon, if we insert in the gas jar that contains nitrogen, then what happens is it continues burning. So this is quite surprising because nitrogen is neither combustible nor it supports combustion, but also the magnesium ribbon continues burning. So why this happens is the nitrogen gas reacts with the metal magnesium, and due to presence of heat, the triple bond is broken down. So the nitrogen can react with magnesium to form magnesium nitride, which is a yellow colored compound. So what we got was yellow powdered, which you also saw in the laboratory. So that confirms the presence of nitrogen in the gas jar. Additionally, to confirm more that if it is nitrogen or not, what additional step we can do is we can add a few drops of water to the magnesium nitride, which is a yellow powder. So the water reacts with magnesium nitride to produce ammonia gas, which has a very peculiar strong smell. So that confirms the test of nitrogen. You also saw all of this while we were preparing gas in the laboratory. Now let us study some physical properties of nitrogen. So you saw that the gas we prepared in the laboratory did not have any color. So nitrogen is colorless. It does not have smell, so it is odorless, and it has no taste, so it is tasteless. Nitrogen gas is lighter than air, and it is sparingly soluble in water, means it is soluble in water in very, very little amount. So it is sparingly soluble in water. And nitrogen gas does not respond to litmus paper, be it red or blue. So it does not change the color of the litmus paper. Hence, we can say that the nitrogen gas is a neutral gas. Nitrogen is neither combustible nor it supports combustion. Now, the another physical property is nitrogen gas can be changed to liquid state at the temperature of about -196 degrees centigrade and into solid state at the temperature of about -210 degrees centigrade. Now, let us study some chemical properties of nitrogen. So, nitrogen reacts with hydrogen under special condition, and the condition is at the temperature of about 450 degrees centigrade and 500 atmosphere pressure in the presence of catalyst iron and the molybdenum promoter, which promotes the catalyst iron. So under these special conditions, the nitrogen gas reacts with hydrogen to form ammonia gas. This process is called Haber's process, and you will study this in detail in next year when you reach class 10. Now, the another chemical property of nitrogen is nitrogen reacts with oxygen to form nitric oxide in presence of an electric arc at the temperature of about 2000 to 3000 degrees centigrade. That is at very high temperature, and in presence of an electric arc, nitrogen and oxygen reacts to form nitric oxide. Another chemical property of oxygen is when we burn metals like magnesium, calcium and aluminium. I've already explained this chemical property in the test as well, but now we'll see along with the equation here. So when burning metals like magnesium, calcium or aluminium is inserted into the gas jar containing nitrogen gas, they continue to burn and they form metallic nitride. The burning magnesium ribbon, which you also saw in the laboratory, when it reacted with nitrogen gas, it formed magnesium nitride, giving yellow colored powder. The another equation here shows the reaction with calcium metal. When nitrogen reacts with calcium, it gives us calcium nitride. Now let us study some uses of nitrogen gas. So nitrogen gas is used to prepare ammonia, nitric acids, which are used to manufacture chemical fertilizers that aids the growth of plants. So nitrogen gas is used to prepare compounds that can be used as a chemical that can be used to manufacture chemical fertilizers for plants. Another use is nitrogen gas is used to fill the packets that contain food material, because what happens is when we fill the packets with nitrogen gas, the oxygen gas and the moisture present in it will be replaced by the nitrogen. So what happens is the nitrogen, due to the presence of nitrogen gas and the absence of oxygen and moisture, the food will not spoil. So it is used in packaging. And the another reason is, since nitrogen gas is an inert gas, it does not readily react with the food substances. So it does not change the quality of the food, or it does not deteriorate the quality of the food. That's why nitrogen gas is used in food packaging, like foods such as chips or fresh meats, etc. So due to this reason, it is used for packaging of food. Another use is nitrogen gas is used to fill the light bulbs that contain tungsten filament, because when you fill it with nitrogen gas, the oxygen gas is replaced. So if the oxygen gas was present in the bulb, it burns the tungsten filament and breaks the filament, since tungsten filament is very thin. So if we use a nitrogen gas, we can prevent the tungsten filament from burning. And since nitrogen itself is an inert gas, it does not burn the tungsten filament as well. So due to these two reasons, the nitrogen gas is used to fill in the bulbs to prevent the tungsten filament from burning. Another use of nitrogen is it liquefies at the temperature of about minus 196.5 degree, which is a physical property of nitrogen. And this property is used in the refrigerator to maintain the cool temperature, so we can store our food and prevent it from spoiling. Now let us study one very important use of nitrogen. So when there is lightning and rain, what happens is, in the atmosphere, we all know that nitrogen and oxygen are abundantly present. So when there is lightning, this nitrogen and oxygen, they combine to form nitrogen oxide. And this nitrogen oxide then reacts with the rainwater to form nitric acid. And this nitric acid, it washes down along with the rain and it reaches the soil. And this nitric acid reacts with some alkali that is present in the soil to form a nitrate salt. This nitrate salt is then taken up by the plant and it uses it to form protein, which is very essential for its growth and survival. So this is also one very important use of nitrogen gas. Now let us test our knowledge about whatever we learned about nitrogen gas by trying to solve this question. So find the correct and incorrect argument from the following. So these are the 4 arguments. Now let us go through each one of them in detail. So nitrogen is a non-combustible gas but supports combustion. Is it true? No, it is not true, because it is a non-combustible gas but it also does not support combustion. So the first statement or the first argument is incorrect. Now second argument, a compound magnesium nitride contains 2 magnesium atoms combined with 1 nitrogen atom. Is this true? Now let us check it through this reaction. So this was there in the chemical properties. So magnesium, when reacts with nitrogen, forms magnesium nitride. Now in magnesium nitride, you can see 3 atoms of magnesium reacts with 2 atoms of nitrogen to form magnesium nitride. But here the argument says that 2 magnesium atom and 1 nitrogen atom. So we can say that the argument is incorrect. Now the third argument. Magnesium burns to produce white solid called magnesium oxide. But if burning magnesium is introduced into nitrogen gas jar, it forms yellow color solid called magnesium nitride. Is it true? Yes, it is true, because burning of magnesium means reaction with oxygen. So magnesium, when reacts with oxygen, it forms magnesium oxide, which is white in color. And when it is introduced into the gas jar, the magnesium reacts with nitrogen to form magnesium nitride, which is the yellow color solid. So this argument is correct. Now the final argument. Nitrogen gas is lighter than oxygen gas. So is this true? Yes, it is correct. Why? Because the molecular weight of nitrogen gas is 28, while the molecular weight of oxygen gas is 32. Since 32 is more than 28, the oxygen gas is heavier than nitrogen gas. So the final statement is also correct. Now I would like to give you this homework. So I'll explain the question to you so that you can write the correct answer to it, and then make sure you show this to your science teacher. So the first question is, nitrogen has got 5 valence electron, even though it does not react easily with other elements to form octet. Why? So nitrogen has 5 valence electron and it requires 3 electron to reach the stable octet state. So why doesn't it react so easily with another element to reach the octet state? So write the answer to this question. Now let us see the second question. What is the difference between the burning of magnesium in air and in nitrogen? So burning of magnesium in air means, I'll give you a hint. It means magnesium reacting with oxygen. And another is burning of magnesium in nitrogen means magnesium reacts with nitrogen. So you have to write the difference between magnesium burning in air and magnesium burning in nitrogen. And the third question is, nitrogen is heavier than hydrogen but lighter than oxygen. Why? I've already told you half of the answer in the previous question we solved. So I hope you can write the remaining half answer yourself and make sure you show this to your science teacher. I hope you understood everything I taught today, and make sure you do your homework and show it to your science teacher, and I'll see you guys in the next class.